Welcome to The Explainer. Today, we're going on a journey to understand how we protect our data in this vast, interconnected world of the internet. We're going to trace the evolution of digital security, all the way from the simple firewalls of the past to the really complex zero-trust model that protects us today.
You click a link and it just works. But have you ever stopped to think about what's actually happening behind the scenes? That one simple click triggers this incredible, complex journey. It's a fascinating story of digital addresses, smart navigation, and a constant battle to keep our data safe. So let's start at the very beginning, with the most basic problem of all. How do our devices even find each other in the first place?
All right, so let's tackle that first big problem. With billions and billions of devices online, how does your computer find the exact one it's looking for on the other side of the planet? Well, the solution starts with something you've probably heard of, the IP address. The easiest way to think about it is like a unique postal address, but for every single device connected to a network. Your phone has one, your laptop has one, even your smart fridge might have one. But, just having an address isn't enough. Imagine a city with millions of houses, but no streets or neighborhoods. It would be chaos, right? That's where subnetting comes in. It's this really clever trick for grouping those addresses into what you can think of as digital neighborhoods. It keeps things organized and, really importantly, it makes communication way faster and more efficient. Okay, so our devices have addresses. They're neatly organized into neighborhoods. Now for the next challenge, how does our data actually find the best route to get to its destination through the massive, tangled web of the internet? And this is a huge navigation problem. Think about it. Billions of addresses, practically endless pathways. How does your data find the fastest, most reliable path in a fraction of a second? To solve that, you basically need a GPS for the entire internet. Now, what's so interesting here is the massive difference in scale. For smaller local networks, like in an office or a school, we use simpler protocols like RIP. It works great for that. But for the entire internet, you need the big guns. You need BGP, the Border Gateway Protocol. This is the powerhouse that literally connects all the huge networks together to make the internet what it is. So our data packets have an address, and they have a route. They're on their way. But, and this is a huge but, the internet can be a pretty dangerous place. This leads us to the next massive problem that had to be solved. How do you protect your private, internal network from all the threats that are lurking just outside? For a long, long time, the classic solution was to build a fortress, and the main wall of that fortress was the firewall. It was designed to be that first strong line of defense, creating a secure perimeter around your private network. But, of course, as threats got smarter, firewalls had to get smarter too. The early ones were stateless. They were like a bouncer who checks the ID of every single person every time they go in or out, but has no memory of them. Then came stateful firewalls. These were the smart guards who could actually remember active conversations, making it way, way harder for anything malicious to slip through. And for decades, this whole castle and moat model, it worked pretty well. It was the standard. But then, the world changed, the way we work changed, and the very idea of a secure perimeter, of those strong castle walls, it started to crumble. Let's just be blunt about it. In the modern world we live in today, the hard truth is that the walls of the digital fortress have pretty much disappeared. That whole approach is broken. And why is it broken? Well, just think about it. Our data isn't locked away in a server room anymore. It's floating around in the cloud. We're not working in one office building. We're working from home, from coffee shops, from everywhere. And we're all using our personal phones and laptops to connect to corporate networks. So the perimeter? What perimeter? It's gone. So this created a massive, brand new problem. If you can't build a wall to keep the bad guys out, what do you do? If you can't trust where a connection is coming from anymore, what can you actually trust? The modern answer is a pretty radical shift in thinking. It's a whole new philosophy called zero trust, and it's all built on one powerful and kind of paranoid idea. So instead of the old way, assuming anything inside the network is safe and should be trusted, zero trust completely flips that on its head. It assumes every single request for access, no matter where it comes from, could be a threat. It trusts nothing by default. So how does that actually work in practice? Well, it's a continuous cycle. You'll verify who and what is trying to connect every single time. Then you give them the absolute bare minimum access they need to do their job, and nothing more. You also chop up your network into tiny, isolated segments so that even if a breach occurs, the damage is contained. And all the while, you're constantly monitoring everything, looking for anything that seems even slightly out of place. And really, a strong zero trust strategy is built on 5 key pillars. You have to verify the user's identity. You have to check the security of their device. Then you move on to securing the network they're on and the applications they're trying to use. And all of that, ultimately, is about protecting the most important thing, the data itself. Zero trust is absolutely the strategy for the world we live in today. But it does leave us with a pretty provocative thought for tomorrow. As threats powered by AI get more and more intelligent and sophisticated, our definition of what it means to verify is going to have to evolve right along with them. Is always verify still going to be enough? That's the big question.